Welcome everybody. Okay, the first order of business, we're going to have an exam coming up here. Not this week, but a week from Wednesday. So it'll be on chapters 1, 2, and 3. When we get into chapter 4, which we will be into chapter 4 before the exam, that will not be on the exam. That also means that next week we will not have a lab. What I'm going to do is I'm going to use the lab time for a catch-up lesson, but it will be on material that is not on the exam, probably in chapter 4. So we're not going to throw that time away. This also means, despite what I say, everybody ready? Despite what I say in the video that I'll be posting tomorrow for the lab this week, which is the ball drop lab, it will not be due next week. It'll be due in 2 weeks. That gives me time to catch up on grading. I have just been absolutely buried to the point where my health could be suffering. So, to the point where it comes down to either doing that or sleeping. I chose to sleep. Okay, I think you know how this is. So this will give me a chance to catch up. So even though I say it's due next Monday or Wednesday, depending when you come in, I don't want you having to have that on top of studying for an exam. Now, about the exam will be given here in this room. Everybody, A and B, regardless of what the schedule says, for an exam everybody's here. What we will be doing though is I will select some of you to take the exam down in room 124. 6 people can take it down there comfortably. And removing 6 people from this room, if you look around us and imagine 6 people somewhere else, that gives us the room for the other members of the class, because this room cannot hold the full class with the COVID guidelines. It can. I might also check the classrooms across the way. And if the classrooms across the way, the smaller classrooms, if one of them is available, I may shuttle some of you over there. This way we can be comfortable and not worry about it. What will the exam be? It will be 10 multiple choice questions. It will be 5 all or nones. The all or nones are the kind of question I had on that quiz where I asked you something, there's a box, you show work, but you put your answer in the box, and if the number's wrong, it's wrong. If the sign is wrong, it's wrong. If the units are wrong, it's wrong. You got to get it right. So there'll be 10 multiple choice, 5 all or none, and there will be 4 problems. You choose the 3 that you wish to do. So there'll be 4 problems. You cannot do one of the problems. You cannot do them all 4 and hope that I'll grade them and get the best one. I ain't doing that. No. You choose your best. You choose which one you don't do. So this gives you an option. The problems are, you get consistency credit in the problems. So with the problems you get partial credit. So I will grade those and go through, you get partial credit. If you screw up the latter part of the problem and because you put raw or incorrect numbers in, you'll still get credit for them. So there'll be 3 problems that you actually do, 5 all or nones, and 10 multiple choice. As far as studying for it, studying the homework problems, but it's also, the test is qualitative too. It's not just about being able to do problems. Okay, so questions like, what is the acceleration of an object when you throw it up and it's all the way up there? The answer is it's still 9.8 downward. That one quiz question, I tripped up a lot of people, even though we carefully did it. I said, how is it, if you throw an object up and it returns back to its release point, the answer is the velocity is the opposite of what it was when it was thrown up. It can't be the same, because that means if you threw it up, it's going up when it comes back down. Now that can't be. but we showed that when you throw an object up and it comes back down, the velocity is reversed. Also, the time up is the same as it takes to come back down. We are going to be using that when we do some of these projectile problems. So that said, does anybody got any questions on any of the homework? You're welcome, on any class, you are welcome to ask questions about the assigned homework. Now I know that some of you are waiting until the last minute to do the homework. That's not why you're given 3 or 4 days to do it. You should try to do it right away, and then there's a possibility of asking a question concerning it. So if you want to ask a question, yes sir, is it JD? Yeah. Hey, I got it, yes sir.
What homework questions were due today?
3-1, 3-2, 3-5, and 3-6. 1, 2, 5, and 6. They're listed. There's no reason ever to know them because I list them under the descriptions on the video. So that if you look under, it says click for more. If you look at the description on YouTube there, and this always upsets me. Why should you have to click for more? You've got 15 terabytes of information. You've got all this screen space. Why the hell do you have to click to see more? But it says click for more, and in that case you'll be able to see it there. Plus you should also just take the notes when you're watching the video, because I mention it at the end of every video. So there's no excuse for not knowing which ones they were. Losing one homework won't kill you, okay, JD? If you forgot to turn one, and one of them is not going to kill you. But you consistently do poorly on the homework. The homework's worth, I think, a total of 15%. That adds up. And of course, if you don't try the homeworks and you don't look at the solutions when the test comes around, you're going to have a bad time doing those problems. Okay, so I think last class we had just barely started projectile motion. And if you're having trouble with free fall vertical motion in chapter 2, you're going to have a lot of trouble with projectile motion, because a large part of solving two-dimensional problems involves doing the one-dimensional vertical problem. Now, I mentioned at the start of the last lesson that when something is only under the influence of gravity, that the acceleration, regardless, people just can't get this. I don't care what direction it's going, how fast it's moving, I don't care about any of that. The acceleration is 9.8 meters per second squared straight down towards the center of the Earth. I don't care if it's going this way, that way. There's no definite relationship between the velocity and the acceleration. There's a relationship between the change in the velocity and the acceleration. That means there's no horizontal component to the acceleration. And that means when you solve the vertical and horizontal problems, you do these separately. The acceleration this way is 0, which means that once it's released, whatever horizontal component of velocity it has does not change. One of the standard things you do in these problems is typically it will say an object is projected upwards. I'm just going to make this up now. Let's make this 40 degrees. And let's make this 25 meters per second. So I am told that the initial velocity is 25 meters per second, 40 degrees above the horizontal. This is typically one of the specifications in this problem. Though, in the turnaround problem, you could be asked to figure this out. In the military ballistics problem, one of the questions is, what angle do I fire it at such that I hit the target? You know how fast it is, you know the range, and you say, what angle do I have to do it? You work backwards. But regardless, you still write the equation starting with this. This is 25 meters a second, 40 degrees above the horizontal. The first thing you want to do if you're given this is figure out the vertical, I like the mask, I love it, vertical and horizontal components of the velocity. Here's the vector, and the latter rule is, to figure out the components, is you enclose the angle that you are given. Well, the angle I'm given is 40 degrees. I could have said an object is projected at an angle of 50 degrees down from the vertical. I could have said that. Rather than calculate the 40 and then do what I'm doing, you could use the 50 degrees. Alright? But in this case we're given the 40, so you make a right triangle that encloses that angle that you're given. So going 25 meters per second at 40 degrees above the vertical is equivalent to going a certain speed horizontally plus a certain speed vertically. We need to find these. Once you have enclosed the angle with the right triangle, you label the three sides. Adjacent, hypotenuse, opposite. The hypotenuse is always the easy one. It's long. The side next to the angle is the adjacent. The side across from it is the opposite. And once you have done that, you also can look at it and decide what is the sine of the two components here. What is the sine of the horizontal component? If we use this coordinate system, so up is positive and to the right is positive, what is the sine of this x component? Plus or minus? Plus. What's the sine of the vertical component? Plus. Okay. You always go immediately. You say, this is V initial. V initial x, you decided it was positive, see? So you put the positive down. You write the hypotenuse. It's always the hypotenuse. And then, if it is the adjacent side, that goes with cosine. Get your calculators and work it out. It's just 25 times 40 cos. Don't trust your instructor. Now let's keep 19.2. Okay, keep an extra 19.2 meters per second. And the initial y velocity we decided is positive. We write down the hypotenuse. If this is cosine, this must be sine. One must be cosine, one must be sine. And this is opposite though, so that means it's sine. And 25 times 40, I hit the sine button, I got 16.1. This is the kind of step that you do in almost all of these. When you're given the initial velocity, you automatically do this. You just automatically do it. You've got to find the components. What we are saying here is that, that's not an hour, let's put it down here, is that going at 25 meters a second, 40 degrees above the horizontal, is the same as going to the right at 19.2 meters per second and going upwards at 16.1 meters a second. That's what you're saying here. Now, since the horizontal component of the acceleration is 0, this never changes. Because a sub x is 0. A sub x is 0. So throughout the entire process, whatever it does, if it's projected upwards at that velocity, during the entire time it moves horizontally at a constant 19.2 meters per second. That does not change. There's no acceleration that way. There's a nice picture in the book. It's kind of hard to see. I can't show it here, but if you look at projectile motion, if you look at page 58, they show an object that is thrown off of a cliff. And if you look at that picture, they break the velocity down into vertical and horizontal components, and you'll see that the horizontal component never changes throughout the whole motion. The vertical component, on the other hand, this piece does change. This is not constant, okay? Because a sub y, now we got to be careful with this coordinate system. What is a sub y? If I draw the acceleration like this, what is the y component of this acceleration? Negative 9.8 meters per second squared. Usually in these problems, when it's a two-dimensional problem, we almost always take up being positive, but you don't have to do that. I'm not going to always do that because many times it's easier if you don't. You have to remember the acceleration is downwards and then get the sign correct, okay? We'll do a couple of problems where we take downwards as being positive. It just makes it easier. But the key thing is that this V final x equals V initial x, which we can simply call V sub x. It never changes. It never changes. It's always the same. So what you've got is this type of motion, okay, moving at constant speed horizontally here, combined with this motion or this motion. So something flying off a cliff is going constantly at a constant velocity this way, while of course it speeds up going down vertically. Now, the other key component, or I shouldn't say component, the other key thing about vertical motion, I said that it is a property of space. Space does have properties. Is that the vertical motion occurs independently of the horizontal motion. They don't affect each other. The time it takes an object to fall from waist level does not change if I happen to be on a train going 80 miles an hour or if I go to Europe on a 300 mile an hour train. If I drop it 1 meter, it takes about 45 hundredths of a second, regardless of how fast I'm going horizontally. But that doesn't mean there isn't something that links the two motions. There is some parameter that is common to both the horizontal and the vertical motions. What is it? What is it? Something involved with the vertical motion is the same as something involved with the horizontal motion. If you take a look at the first problem there, driving off a cliff. So a car drives off a cliff and then hits the car down below. Ever see Triple X when they drive off the bridge? I do love gratuitous destruction of automobiles in movies. I am a big fan of that. Just blow them all up. I think it's great. The time, people, the time it moves vertically is exactly the same as the time that it moves horizontally. It cannot move horizontally for a different time it moves vertically if it's the same event. The time is the common thing. And what this means is, in many cases, you can use either the vertical or the horizontal to get the time, and then you can go and plug that into the other motion and use it. So let's take a look at this. Let's take a look at driving off a cliff. One of my favorite driving off a cliff ones is, have you seen Groundhog Day? in Groundhog Day, Bill Murray gets the groundhog in his truck. He's stuck in a time loop, and he can't die. So he takes the little guy and he drives right off the cliff, straight off, and down into the quarry. Okay. So let's look at this problem and get an initial idea of how to do these. So here's what we're given. This is example 3-5. Now, you will see on page 60 some equations there. I encourage you to not memorize those equations. Remember the equations from chapter 2 for constant acceleration. And then you put in either plus or minus 9.8 meters per second squared, depending on your coordinate system. Why try to memorize more equations? It's the same situation. So this is example 3-5. Example 3-5. And we're told that a movie stunt driver on a bike speeds off a 50-meter high cliff, and he wants to hit 90 meters below. How fast must he go? Now, as always, thou shalt draw a picture. You must draw a picture to help you visualize. Here's this. We are told that he goes horizontally off a cliff. It changes if he uses a ramp. That's important. Horizontally. And arcs down, and boom, hits down here. We are told that he hits 90 meters away. We are told the cliff is 50 meters high. And I hate these expensive markers. Okay? Now, the question is, how fast does he have to drive off the cliff? Now, you must draw a coordinate system and show me where your origin is at. Now, I'll be consistent with the book. They showed it there. I like to draw it off to the side. So I'm going to use this coordinate system, and I'll put it at the top of the cliff. So you draw the picture, choose a coordinate system, an origin and an orientation. And from this, we know that a sub x is equal to 0, and a sub y, what is it? Plus or minus?
Minus.
Downwards is the negative direction. Up is plus, down is minus. Gravity is down, the acceleration due to gravity. So the acceleration is minus 9.8 meters per second squared in the y direction. Now, if we diagram his initial velocity, if it's horizontal, that is the initial velocity. It is aligned with the plus x axis. If you use this coordinate system here, you should use it here. What is the initial y component of velocity? Yeah.
0.
Is it John?
Yeah.
I'm learning a few names anyway. Okay. V initial y is equal to 0. Now V initial x, that is what we want. That is what we want. What is V initial x? That is what we want. So we want v initial x. Now, what can we find? Well, let's see, we haven't elucidated everything. What's x initial? What's x initial? I put this here. What's x initial? 0. What's x final? 90 meters, see? What's y initial? What is y final? Good. Who said negative? Yes, negative. Not positive. It is in the negative direction. So we've got x initial, x final, y initial, y final. We've got v initial y. We've got a sub y. What can we find? Don't worry about what's asked. What can we figure out?
Change in distance.
We know the change. Yes, we can. Can we find? We can find delta y, correct? And we can find delta x. We can do that. Delta y is equal to y final minus y initial. Let's go for it. Which is negative 50 meters minus 0 is negative 50 meters. Okay, so we could find that. That just might be useful. What else can we find? Yes. John, how? How am I going to find the time? You see, what we're saying here, folks, to reiterate, the time it takes it to move 90 meters horizontally is the time it takes it to fall from rest 50 meters. While it's moving horizontally out to the 90 meter mark, it's falling 50 meters. So we go back to chapter 2 and we ask the problem. A ball is dropped from rest and falls 50 meters. How far or how long does it take? Well, what you have to do is you have to write out the y equations. So you should write out the y equations, which is v final. You have to put y's on these. Since the y acceleration is constant, okay, all we ought to do is change all the x's in those equations from chapter 2 to y's. That's all we're doing. That's all we're doing. And then we have v final y is v initial y plus ay times t. V bar in the y direction is v initial y plus v final y over 2. Y final is y initial plus v initial sub y. So we've got to put a y on here. Times time plus 1/2 ay t squared. And we can also say the average velocity in the y direction is delta y over t, or delta t. So John, which one can get me the time? If you start going through this, what you do is, as I said, check off those things that you know. We don't know v final y, but we know v initial y. We know 2. Okay. We could find the final y velocity, couldn't we? We could find that. But let's keep going. We don't know the time. We don't know v final y, but we know y initial. We know v initial y. We know a sub y. We can use this. Y final is 0 plus 0 plus 1/2 ay t squared. The initial y is 0, v initial y is 0, so we get that y final is 1/2 a sub y t squared. John, tell me what to do. How do I find the time? Tell me what to do.
You multiply
It's real loud so the camera can pick it up. Multiply by,
by 2
yes?
and divide by a.
Yes.
And square root it all.
Okay, so what I like to do is y final times 2 over a sub y is equal to t squared. And I like to do this first, John, and then take the square root when you're done. And I'll show you why. All right? Now, what's y final?
Negative 50.
Negative 50. Now, that might cause me a concern. Hold on. Let's put the 2 in there. Why might that negative sign scare me just a little bit?
Because you square rooted.
Yeah. But wait, let's just keep going. You can't take the square root of a negative number, but what is a sub y? Negative 9.8. And when we divide by units, we reciprocate and multiply. And negative over negative gives us plus, so we're going to be okay. So you can actually, let's work that out. Don't take the square root yet. Get your calculator and do it. Everybody, where's your calculator? Get your calculator out. None of you people are good enough to not practice your calculator. 2 times 50 divided by 9.8, about 10.2. Now keep it all in there. So this is 10.2 seconds squared is equal to t squared. And now you take the square root of both. You just take the square root. We got a positive number, and I get 3.19 seconds. See? So it falls for 3.19 seconds. Meanwhile, it's moving horizontally at this velocity, 90 meters. So what we have done is we have ignored the horizontal part of the problem. Just to hell with it. It's doing it, to heck with it. It's dropping from rest, and it's hitting the ground 3.19 seconds later. By the way, now you can find the final y velocity. You could find this. There's a bunch of other stuff, but that's not what we're asked for. So now we come back and we say, if we look at the horizontal problem has 0 acceleration. And that says that x final is x initial plus v times t. Okay? This is essentially, you can write this, that the average velocity is the same, so x initial is 0, and we should say this is v initial x. So, if we divide x final by t, v initial x is x final divided by the time. It has to go 90 meters. It has to do that in 3.19 seconds. We're going to get meters per second. And I've actually got the, here's a little trick, just listen up. I've already got this 3.19 in my calculator. All I got to do is reciprocate it, hit shift 1 over x, and then multiply it by 90, and I got 28.2 meters per second. And that should be exactly what the textbook got. All right. You notice that I didn't look at the textbook while I did this problem. This is what I call free-forming. I just do it from up here. I draw the picture though. While it is falling for 3.19 seconds and accelerating and falling 50 meters, it's going horizontally at 28.2 meters a second, and that means it will travel out 90 meters before it hits. Now, this could easily be turned around. The turnaround problem would be a motorcyclist drives horizontally off a cliff at 28.2 meters per second and strikes the ground 90 meters from the base of the cliff. How tall is the cliff? How tall is the cliff? See? Whenever you drive horizontally, it means that the vertical component of the velocity, this is the condition for a horizontal initial velocity. It's the same as if it were just dropped. It's the same as if it were just dropped. And here is something else. All right? But first of all, any questions? Any questions there? So let me ask this. The biker is driving along. How the hell do you draw a motorcycle? It's got to be a Honda motorcycle, by the way. None of this Harley stuff. It's got to be a Honda motorcycle because I rode Hondas, okay? All right? But here he is, and at the moment he drives off the cliff, he knocks a pebble off the cliff. There's a little pebble sitting there, and he knocks it, and the pebble starts falling down. Which is correct? He hits the ground before the pebble hits at the same time, or the pebble hits before him because it's not moving horizontally. Yes?
They did it at the same time?
The same time. Exactly the same time. Exactly the same time. So if he knocks some dirt here and it falls straight down and there's no air resistance and stuff like that, it will hit the ground the same time that he does. Ignoring air resistance now. Ignoring air resistance. Questions or comments?
How does he survive that fall?
Oh, there's a boat or a truck here with an air mattress in, a big air mattress. So what happens if he goes too fast? Does he survive the fall? Splat. No, yeah. Do you ever wonder how Wile E. Coyote always comes back? Wile E. Coyote falls off a cliff millions of times and he's always, you know. And what do they show? What did they show in those cartoons which is incorrect? Yeah, it's like, and then he suddenly falls. You know, I can't do it with him. It's like, yeah, I can't do it with the mask on. Mel Brooks is the guy, or not Mel Brooks, Mel Blanc is the guy that did all those voice characterizations. That guy got rich just on doing that kind of stuff I just did. He got paid to do that, okay? Yeah, you don't hover there then suddenly fall. You fall immediately. All right, let's start and look at the football problem. And by the way, we will be having our quiz on this Wednesday. The day we have the test, we will not have a quiz, okay? So let's get that squared away right now. So you folks will be taking the quiz online, and the folks that are watching on camera will be taking it live. Let's look at the football problem. The football problem is also a typical Navy ballistics problem. It's quite impressive if you can go down to, I forget where it is in North Carolina. I think it's the USS North Carolina is the battleship they have down there. Amazing. Just absolutely amazing what these battleships were like. Guns that would shoot a bullet that was this big. Okay? 25 miles. Now in that case you can't ignore air resistance. But in the football problem, a football is kicked at some initial velocity. So the football problem is the way I always call it. We do these problems because they illustrate certain things, and this is actually example 3-6. We probably won't get all the way through it, but the key thing here is a football is kicked at some initial velocity, at some angle. Here we're told it's 37 degrees. And it's kicked at 20 meters a second. That's pretty respectable. Now that's the speed. That's the speed. And it follows an arch and then comes back down like that. And we're again going to ignore air resistance. But there are all kinds of questions you can ask. How far did it go? How long was it in the air? How high did it get? How high did it get? Okay, and things like that. But one of the most basic things is, what is the time in the air? And how long, what was the range? Okay. Now what we do, we'll still put our coordinate system here, like so, and we'll put this like that. And the first things we do, we find the x and the y components of this initial velocity. Now this is only at the moment that it's kicked, the moment that it leaves his foot. Just a moment after that, the angle has changed and the speed has changed and everything. So, but let us find the initial and final components. So step one is find the components of the initial velocity. Well, from this, complete the triangle enclosing the angle given. This is adjacent, opposite. 20 meters a second is the hypotenuse. The initial x component is, by inspection, positive 20 meters per second. This is the adjacent side, cosine 37 degrees. And likewise, the y component is also positive, times the hypotenuse times the sine. Now, don't make the mistake of always putting cosine with x. When the angle's measured from the x-axis, that works, but if the angle is measured from the vertical, the cosine and sine are switched. So don't just automatically go to that. And when you calculate these out, you get 16 and 12. I'm not going to worry about the 16.0 and the 12.0. So initially, it's projected horizontally at 16 meters a second, while it's projected vertically at 12 meters a second. This is going to drop, go to 0, and then it's going to become negative. It's going to become negative. Now, I'm going to go off on a tangent because we only got 5 minutes before we get into this, but I'm going to ask something that could be a very complicated question. What angle does it strike the ground? If I wanted to take a shoot that was just the size of the football, and of course the football won't make what's around, and I aim that so that it would go right into it, what angle would that be? So I want to ask, when it hits the ground, what is, let's call that phi. What angle does it hit the ground? Now, you could go through all the calculations and so forth, but if I draw the diagram, what is the x component of the velocity when it hits the ground? No, I mean, I'm not talking about after it stopped. I'm saying right before it hits the ground. How fast is it going sideways? It's coming down. How fast is it going? It's on the board. Which one? Yes! This never changes. When it hits the ground, it goes 16 meters a second the entire time coming down, and then it strikes. The horizontal component when it hits the ground is 16 meters per second. The x component of the velocity never changes. Now, what's the y component of the velocity when it hits the ground? Who said it? Is it Alex? Yeah. God, I'm learning some names. Yes! Why? Well, actually, no, it's not 12. You're wrong. What is it? Negative 12. See, we said that when an object is projected upwards and comes back down, the velocity is reversed. So it is coming back down. Now that's the magnitude like that. And so if you look at this compared to that, and we calculate this angle has a 16 and a 12, a 16 and a 12. By God, this is 37 degrees. You can do that. You can say the opposite. Oh, this is 12 meters per second. This is 16 meters per second. The angle that it comes in, when it comes in like this, okay, this angle, opposite angles are the same, right? Alternate interiors. It hits at the same angle. If it was like this, 37 degrees up, it hits here, 37 degrees up. No calculation required.
Is that just like a constant rule, like across?
As long as the ground is flat,
Gotcha.
I mean, if the ground is a hill, and as long as the final y value is the same as the initial y value, this will be true. See, it's surprising. It's surprising. So it hits, comes back down. All right. I'm going to stop right there. Let me see if there is the last. Let me see if I can do. Let's do 18 and 20. 3-18 and 3-20. So for you folks, these will be due on Friday. Otherwise, they would be due for the other folks on Monday, correct? Yes. These are they're horizontal problems. Autumn?
I just wanted to ask, the 8 and 9, was I supposed to turn that in today also? Or is that
No,
Friday also?
no, those were assigned later, and so they're due next class or something like that. I forget.
Friday. So
Yep,
8
okay.
and 9 are due Friday, and 18 and 20 are also due Friday.
That's going to be correct. Yes.
Okay.
It's kind of weird. And what you need to do is you need to go and look at 18 and 19, or 18 and 20 right now. That goes for the people watching in the video too. You need to look at it right now, not the day, not 2 hours before it's due. All right. All right. Let's stop it there. This is very surprising though that it hits at the same angle. Okay. That's pretty.